So we want to find the equations of lines that contain 2 points. So first off, I have 3, 7 and -5, -9. Let's take a look at those on Desmos. So I've put those in. We have -5, -9, and 3, 7. We want to find the slope. Now recall that slope is rise over run. How far do I rise? How far do I run? Now just notice something. This is ascending from left to right, so I know the slope will be positive. So looking at this, my rise or my change in y is up how many? 9 here and then 7 more, a total of rising 16. So my change in y is plus 16 over the change in x. What is that going to be? Let's take a look at our picture again. So we rise 16. How far do we have to go over? Over 5 and then 3 more, over 8 more. So our change in x is plus 8. So putting that together, we get a slope of 16 over 8, which is plus 2. When I want to find the y-intercept, the way I do that is I like to use y equals mx plus b. I like to plug in values. So I have the point 3, 7. I can let 7 be y. M is 2. X is 3. Plus 1. 7 is 6 plus 1. Excuse me, plus b. 7 is 6 plus b, and indeed b is 1. So what is my equation? My equation is y equals mx plus b. Y equals, the m was 2, 2x plus 1. So we can go ahead and graph that and see if that works out to be the case. Y equals 2x plus 1. Does it go between both of those points? It sure does. Now, the way that this is usually done, right, is to say the slope m is y2 minus y1 over x2 minus x1, which you'll notice the process is really the same. -9 minus 7 over -5 minus 3. We get -16 over -8, and we get m is 2. And then you can also use point slope form. Point slope form is y minus y1 equals m times x minus x1. So if I'm using the point 37, my equation would have been y minus y1 is 7 equals m 2 times x minus x1, 3. So I get y minus 7 equals 2 times x minus 3. Y minus 7 equals 2x minus 6, adding 7 to both sides. I get my answer this way as well. Y equals 2x plus 1 in slope-intercept form. The advantage of slope-intercept form is that it is in function form, so we can graph it on a graphing calculator or such things. Okay, let's take a look at our next question. It gives us the points 2, -4, and -1, 5. And I'm going to go ahead and say that the slope is rise over run. Or y2 minus y1 over x2 minus x1. Now, how am I going to get the rise? I'm going to think of it this way first, from -4 to 5. From -4 to 5 is going up. From 4 below 0 to 5 above 0, from 4 below to 5 above is up 9. Notice that's also 5 minus -4. x2 minus x1, I'm starting at 2, I'm going to -1. Which direction am I going? From 2 to -1 is going down. Going down how far? Going down 3. But notice that's also -1 minus 2. So try to think of it both ways. That gives me a slope of -3. So my next move with the procedure I prefer is to go with y equals mx plus b. We have our m here is -3. And x and y are one of the points I want to use, so I'll just choose the first one. So plug in -4 for y equals m, -3 for x, excuse me, for m, 2 for x plus b. -4 is -6 plus b. add 6 to both sides, and we get 6 minus 4 is 2. 2 equals b. So we had m equals -3, and we had 2 equals b. Remember, our equation is y equals mx plus b, y equals m -3x plus 2. Now let's check that on Desmos. Our 2 points are 2, -4, and 1, -1, 5. And we believe our equation is y equals -3x plus 2. And sure enough, it seems to go through both of those points. Whoops, I hit label here. That'd be better. So the green line, y equals -3x plus 2, indeed intersects those 2 points. And just to show you the alternate strategy, we have our m of -3. We have our point of 2, -4. We could have used point slope form. Y minus y1 is m times x minus x1. Y minus -4 is m -3 times x minus x1, x minus 2. So y plus 4 is -3x plus 6, subtracting 4 from both sides. And you get y equals -3x plus 2, using the point slope form as our strategy. So another question on finding the equation of lines. This time we have 4, -1 and -3, 5. Let's take a look at that. 4, -1 and -3, 5. Let's just see if we can think it through this time. Slope is change in y over change in x. From -1 to 5, that's our y's, starting at 1 below 0, going to 5 above 0, that's increasing 6, up 6. Change in x, starting at 4, going down to -3. Visualize that. How is that changing? From +4 to -3 is down 7. So I get a slope of -6/7. I've got to choose one of those points. It doesn't matter which one I choose. Maybe I'll choose -3, 5 this time. And I want to solve for b. So I'm going to say y equals mx plus b. The y is 5. The m is -6/7. The x is -3 plus b. So I get 5 is -6/7 times -3 over 1, which is +18/7 plus b. And I need to subtract 18/7 from both sides. 5 minus 18/7, what is that going to give us? 5 minus 18/7 is 17/7. Remember, that's not your answer. I need to know m and I need to know b. M is -6/7. B, we believe, is 17/7. So our equation would be y equals mx plus b. So y equals m -6/7 x plus 17/7. Well, let's check that on Desmos, see if that line indeed goes through those 2 points. So the 2 points we have are 4, -1 and -3, 5. And we'll label those so we can see them nicely. And then we're going to ask, does y equal -6 over 7x plus 17/7? Does it intersect both of those points? And it sure looks like it does. So we feel pretty good about that. And you certainly could have done this with point slope form as well. If you prefer that, your point, maybe this time I'll use 4, -1 as the point instead, just to change things up. And the slope is -6/7. Point slope form, y minus y1 is m times x minus x1. So y minus -1, y plus 1, and -6/7, x minus x1, x minus 4. y plus 1 is negative 6/7 of x plus 24/7. Subtract 1 from both sides, and we wind up with y equals negative 6/7 x plus 24/7 minus 1. 24/7 minus 1 is 17/7. So that agrees with what we had up there. So a couple different approaches. I like solving for b, but certainly there's nothing wrong with using point slope form. Our next question in this set is 2, -3 and 5, -3. So how are we going to do that? 2, -3 and 5, -3. Whichever strategy you use, we are going to start with slope. Slope is change in y over change in x, or for emphasis, I'll even say, fine, y2 minus y1 over x2 minus x1. y2, -3 minus y1, -3 over x2, 5 minus 2. -3 minus -3 is -3 plus 3 over 3, which is 0 over 3, which is 0. Slope is 0. I want to find b, so I still want to use my point. This time I'll use 2, -3, and my equation is y equals mx plus b. Let me go ahead and solve for b. Y is -3, m is 0, x is 2 plus b, and I get -3 is 0 plus b. I get -3 is b. Okay. So we have m is 0, b is -3. Slope-intercept form, y equals mx plus b. Y equals 0x plus -3, which is the same as saying y equals -3. Now, notice here, y equals -3, y equals -3. So you might have been able to look at that directly and just say the equation for that is y equals -3. And indeed it is. Quickly on Desmos. Points 2, -3 and 5, -3. And the equation is y equals -3, and no surprise, a horizontal line with a slope of 0. My metaphor is cross-country skiing. If you're trying to ski on this, you're going to go 0 miles an hour if the hill's doing the work. You've got to do the work if you want to move. Okay, we have one more in this set to look at. 1, 4 and 1, -2. We want to find the equation of that line in slope-intercept form if it's possible. So what is the slope? Change in y over change in x. Change in y from 4 to -2 is down 6. From 1 to 1 is 0. No good. Cannot divide by 0. That's not a real number. There is no slope. Not a 0 slope, no slope. Slope is undefined. So let's look at our numbers here. 1, 4, 1, -2. What do we notice? Well, in this case, the x value is 1. In this case, the x value is 1. So the equation, again, not in slope-intercept form because slope-intercept form is impossible. Because there is no slope. But I can get the equation of the line. What is the equation of the line? The x values are 1. Answer is x equals 1. So just again, a quick look on Desmos to show you that. The points are 1, 4 and 1, -2. And we believe the equation is x equals 1. And sure enough, that is a vertical line. Vertical line has no slope. If you're skiing on that, you're going to have a real problem. In a sense, it's infinite, right? So that's not going to work. That is not a slope. That is not skiable. There is no way to write that in slope-intercept form. But our equation is x equals 1.